Okay, we've got HonAlg2 notes, Chapter 1, Section 5, continued, Part 2. We already did absolute value equations. Now we're going to talk about absolute value inequalities and how we go about solving these absolute value inequalities. Well, number one, just like we did before, you have to make sure that the absolute value expression on one side of the inequality is isolated. That is, nothing in front of it, nothing behind it. So if we take a peek at our two examples here, this one's isolated already with the inequality. Okay, if I cover it up, nothing in the front of it, nothing behind it. But this one over here, if I cover this up, I notice that there's a 3 in front of the bars. I have to get rid of that. So that's this isolate step. Okay, you got to make sure that you get rid of it first. Then you determine if you have an and or an or statement. Okay, which is determined by the inequality symbols. The and is going to involve less than, and it could also involve less than or equal to. And then the or is the greater than, or the greater than or equal to. And now a little clever way of remembering that the greater than is the or is to simply think of the word greater spelled as greater. Okay, so when you're looking at these, like I'm looking at this problem here, the absolute value of x minus 5 is greater than or equal to 8. And so if I enunciate that or part of the word greater, then I know this is my or. Okay, and why would we want to know that? Well, an or situation is going to give me a split graph. So maybe I'm bracket, and I'm shading either to the right or to the left. So a greater than situation, the or situation, is going to give me a split graph. The and is the between graph. Okay, and so, I would be shading between two particular values. Okay, and that's what happens when you have an and. We are shading between this value and that value, hence the word and. Okay, so setting up, it's still two cases. You're going to take what's inside the absolute value bars and you're going to write it twice for our two cases. We're going to use the given inequality symbol for the first case, and we're going to keep the sign of the given value again for the first case. For the second case, you're going to switch or flip the inequality symbol and use the opposite of the given value for case 2. And then we're going to solve both inequalities. Okay, so that's the setup. You just have to remember the and the or, and also the fact that you've got to isolate that first. This one is already isolated. So here's my two cases. I take what's inside the bars, I keep the symbol, I keep the sign. I take what's inside the bars, I flip the symbol, and I switch the sign. So you're going to flip and switch. Now I'm going to solve. X is greater than or equal to 13. And I'm going to add 5 to both sides on this one. X is less than or equal to negative 3. Now I'm going to draw my number line. I need a negative 3 on the number line and a positive 13. Those are my boundaries. So I'm going to put negative 3 here. We always like to show 0 on the number line. And I'm going to put positive 13 over here. All right. Boom, boom, boom. Now I got to figure out the shading. Well, I'm going to start at negative 13, include it with a bracket, and shade it to the right. Remember, you need the thick arrow to indicate that the shading keeps on going. And at negative 3, I'm bracketing and I'm shading to the left, and a thick arrow. Now, recall that this side of the number line is going to negative infinity. This side of the number line is going to positive infinity, because I have to give my answer in interval notation, because it's inequalities. So I say x is an element of values that go from negative infinity up to and including negative 3. And I'm going to bring together with it elements that start at 13, including 13, and going to positive infinity. All that stuff in between, they are not solutions. Okay, so this is my solution set, if you will. Now, you really should always check these, check your values, but the values that you choose to check have to be in that shaded part, okay? So always check values in the shaded section. If you choose a value that's not in the shaded section, you're going to get a false, okay? So make sure, okay, so if I wanted to test 0, 0 should be false. 0 should make this false. So let me substitute a 0 in here. 0 subtract 5 is -5. Absolute value -5 is 5. Is 5 greater than or equal to 8? No, it's not, so that's false. Over here, let's test a -5, because -5 lives on this piece of the number line. -5 subtract 5 is -10. Absolute value of -10 is +10. Is +10 greater than or equal to 8? Sure, of course it is. And again, you can pick a value over here. Let's pick a 20. 20 subtract 5 is 15. Absolute value of 15 is 15. Is 15 greater than or equal to 8? And you say, why, yes, yes it is. And so you can be sure that these parts here are your solutions. Okay, again, the greater is the or gives me a split graph. Example 2, I have to get rid of the 3 first because the absolute value expression on the left side of the inequality is not isolated. So you have to divide first. So you get a y subtract 9 less than, I'm dividing, 27 divided by 3 is 9. Now I can set up my two cases. Case 1 is take what's in the bars out, keep the symbol, keep the sign. Case 2 is take what's in the bars out, flip the symbol, switch the sign. Okay, now I'm going to add 9 to both sides. Y is less than 18. I'm going to add 9 to the other side. Y is greater than 0. Now, this is a less than. That's an and. And I should be expecting a shading in between graph. Notice my boundary points for the number line, 0 and 18. I'm going to put 0 here. I'm going to put 18 up here, just to show that they're a little bit farther, you know, pretty far apart. And now I want to shade. Well, I'm starting at 18, not including it, so that's a parenthesis. And I'm shading to the left because elements to the left of 18 are less than. So I'm going this way with it. Here at 0, I'm starting at 0. I'm shading to the right. Elements to the right of 0 are greater than it. And it's going to meet here in the middle. So solutions to this inequality are between 0 and 18. Okay, so let's write our solution set. X, actually, technically, this should be y is an element of 0, 18. Parentheses, because it's not equal to. Okay, so technically it's y because my variable that I was using was y. So y is an element of the interval 0 to 18, not including 0, not including 18, but everything in between. Okay, so hopefully this isn't too terribly difficult for you to comprehend. I'm going to take a look at 3 more examples. I'm going to go through them fairly quickly. You could always rewind the video if I'm speaking too quickly. This is an less than, which is an and situation. Now, be careful, because if there's any time that there's a leading negative, and when you divide by that negative, that's going to flip the inequality symbol, and that changes an and to an or an or to an and. So be cognizant of that. All right, so I've got absolute value of 6y, subtract 2, I'm going to subtract 4, keep the symbol, and that's going to be what, 18? Now I'm ready for my two cases. 6y subtract 2, keep the symbol, keep the sign. Case 2, 6y subtract 2, flip the symbol, switch the sign. Solve these many inequalities. I'm going to add 2, so 6y is less than 20. Divide by 6, y is less than 20 over 6, which is going to simplify to 10 over 3. Because they're both even, I could simplify this. All right, case 2. I'm going to add 2. 6y greater than, add that is negative 16. Divide y is greater than negative 16 over 6. Simplify y is greater than negative 8 over 3. Okay, now I'm going to graph. You kind of have to, if you're going to put this on a number line that's already given to you, you have to estimate 10 thirds and negative 8 thirds. But for the purposes of, I don't have a number line, and I've got a positive number and a negative number, I'm going to put 0 here. I'm just going to say 10 thirds is to the right of 0. 10 thirds is what, like 3 1/3? So I'm going to say 10 thirds is here. And negative 8 thirds, I'm going to say, well, negative 8 thirds would be about here. That's what, 2 2/3, negative 2 2/3. And now you got to ask yourself, Seth, is this parentheses or brackets? And you say parentheses because it's not included. And I know it's an and situation, so it should be shading in between. At negative 8 thirds, shade to the right. At 10 thirds, shade to the left. So I am correct in my thinking that this is an and. And now I'm going to give my solution set in terms of y. Y is an element of the interval from negative 8 thirds, not including it, to 10 thirds, not including it. Not too terrible, I don't think. Sometimes these get a little bit busy with fractions. You have a calculator to help you with that. Make sure you know how to convert your calculator from decimal form to fraction form. The calculators are a little bit different. If it gives you a mixed number, please convert that mixed number to an improper fraction. Okay, example 4. Notice, I've got this to get rid of by, it's a fraction, so I know I'm going to get rid of this by multiplying both sides of the inequality by 4. But before I do that, I have to follow PEMDAS. I have to get rid of this first, right? Solving inequalities and equations is really PEMDAS in reverse, because you're reversing it. All right, so this becomes 1/4 times the absolute value of x subtract 3. I'm going to subtract 2 from both sides, so that gives me a negative 1. Now I'm going to multiply both sides of the equation by a positive 4. When I multiply by a positive 4, this is not going to cause me to flip the inequality symbol, because I am multiplying by a positive, not a negative. So this over here equals 1, leaving me with the absolute value of x minus 3 by itself, less than negative 4. When is the absolute value of this less than negative 4? Well, I'm going to say that, is a positive number ever going to be less than a negative number? And you're going to say, no. So you should expect no solution here. But let's go through the process. We know this is an and situation because it's less than. And so let's set it up. Let's set up our two cases and actually physically see what happens. Because sometimes students aren't looking for this, and they go through the process. So let's pretend we didn't see that, we didn't know that. We're going to take what's inside the bars, keep it. We're going to take what's inside the bars, x minus 3, we're going to flip it, and we're going to switch it. Okay, now we're going to solve this. We're going to say x is less than negative 1, and here we're going to say x is greater than 7. So this negative 1 is to the left of 7. This is going to graph like an OR. this takes on the OR split graph. Okay, so when that happens, you're saying it's an and it didn't switch to an or. But you end up with, like, this is going to be an or. Something's not jiving here. It's not matching up. Then look at the original problem. Is it possible to take a positive number, add 2 to it, and then have it be less than 1? Is it possible to take some positive number, even if x is 0 here? This is going to be 3/4. That's going to be a positive number. So it doesn't matter how tiny the fraction is. Is it possible to have a number between 0 and 1, a tiny number, and then add 2 to it and have it be less than 1? And your answer is no, it's not. So that's your question. You know, when this happens, you're going to take a look back and say, is this possible? Is it possible to take a positive number, add 2 to it, and have it be less than 1? And your answer is no, that's not possible. So guess what? This has no solution. And you can say we've got empty set here. Okay, so if you have questions on that, either rewind, watch this part of the video again, or put a comment on the homework discussion post. Okay, one more. Example 5. Is a positive, can a positive be greater than or equal to 0? Sure, it could. This is an OR. I'm expecting a split graph, shading to the left or shading to the right. I guess I'll keep the green color. Absolute value expression is already isolated, so set up 2 cases. 3 times z plus 15 greater than or equal to 0. Case 2, 3z plus 15 less than or equal to, now remember, 0 doesn't have a sign, so I can't change the sign. I can flip the symbol, but I can't change the sign because 0 doesn't have a sign. All right, I'm going to solve. 3z greater than or equal to negative 15 divide z greater than or equal to negative 5. Take the 15 over. 3z less than or equal to negative 15. Z, after I divide, less than or equal to negative 5. So, what the heck's going on here? We're saying, well, let's graph this. I only have one boundary point. It's negative 5. I'm going to put 0 up here. So we're saying at negative 5, put a bracket and shade to the right. And then here we're saying at negative 5, put a bracket and shade to the left. Well, isn't that really going from negative infinity to positive infinity? Again, in the original problem, is any positive number greater than or equal to 0? And you have to say, yes. I can test it. Test the 0. Test a 0. A 0 would be absolute value of 3 times 0 plus 15 greater than or equal to 0. This is 15 bigger than or equal to 0. Yeah, that works. Test, I don't know, negative 10. Negative 10 is on that interval. 3 multiplied with negative 10 plus 15 bigger than or equal to 0. And we're like, oh, this is negative 30 plus 15 is negative 15, but the absolute value of that is 15. Is 15 bigger than or equal to 0? Yes, it works. And so my solution then here, and I'm convinced that Z is an element of all real numbers, negative to positive infinity. And that's all we got. Sometimes, again, they're a little bit tricky. Keep in mind that this might not be an equal to situation, and if it's not, then you have to do parentheses, and then you'd have back-to-back parentheses. So it'd be all real numbers except negative 5 if this equal to bar wasn't there. So be on the lookout for that. And folks, some of you are not watching the videos all the way to the end. You must watch the videos all the way to the end, and furthermore, you must watch the videos. I give you tips and tricks on how to think about this and how to get this stuff done quicker with those tips and tricks. Anyhow, if you have any questions, put on the discussion post. Have a great day.